Okay. Okay, nice to know you're there. You're live with Sa Majesty is the World Science Channel, and I am here for you. So, okay. You don't even know how very special you are. Make it move, make it groove. Make it move, make it groove. Okay, how it will go today is that I will first give you some likely questions, as you can see there on the screen. Then after which you now come up with your questions, and I'm here to help you out. Score not less than 90 in this upcoming JAMB and the mock you're about to write also. So remember that I am here to serve you, as you can see there on the screen. I am live and I'm here for your questions. So you endeavor to bring your questions as quickly as possible and make them snappy, and remember that you should save time. This live stream will end exactly around it's just a 45 minutes live stream, and we have started already. So first I will just give you time to look at the questions again. So see question 1 and the options there. Okay, giving you time to copy questions 6 and 7. So I will answer 10 questions only in this live stream. Then you come up with your own question. Next time we'll answer another 10 questions also. Check if these questions are actually funny. So this is question 8 and 9. Screenshot it if you can. So these 10 questions, these are the questions we'll take for today. So Mercury, you are saying, hey, I'm still there. Trigona Pyramida, okay, is that your answer? At least that's a nice attempt, of course. But let's see your ability. I love you all. You're trying a bit. But we will take the question one after the other, of course, after each one, as you can see there. So what we do next now is to go to our answer board. We bring this up. So over here, I'll give you the answers, and before then, I have to lift the questions. So we have question number 1 here. Just for you to see clearly, the question says, how many lone pairs are present in a chlorine molecule? So option A says 1, option B says 4, option C says 6, option D says 0. Let us see the correct answer now. I will minimize this, put it aside, and I give you the solution to that. Okay, before that, I think this question is blocking a bit. Okay, the answer will come now after I will prove it here. You see it. So remember, chlorine is diatomic, as you can see here now. Chlorine is diatomic, meaning we write Cl2. Simple. Then in one chlorine, the electronic configuration shows that chlorine is number 17. So we have KLM, which means 2, 8, and 7. So one chlorine atom will have 7 electrons in the outermost shell. Then having 2 chlorine will be in this form. So these have 7. We have 1, 2, 3, 4, 5, and 6. Then the other one will be here. Then this other one will also have 2 here. 2, 4, 6, and 8. So this is chlorine atom. By so doing, you have that this is Cl bonding to Cl, where here is the bond. So lone pair means the one that is not used in bond formation. So by so doing, what do we have here? We have in one of the atoms, you have 1, 2, 3, 4, 5, and 6. So in chlorine molecule, there are 6 lone pairs. So the correct answer here is option C, as you can see. So there are 6 lone pairs of electrons in a chlorine molecule. Then we move on to the next question, which says, that's question number 2, says, when iron rusts, you should be careful with this question. Question number 2 is telling us that when iron rusts, it becomes stronger, heavier, or more acidic or lighter. Simple. Some may answer straightforward that when iron rusts, it becomes lighter. No, it is not true. When iron rusts, it is not getting lighter at all. When an iron rusts, it gets heavier, because rusting is actually a chemical reaction whereby an ion combines with oxygen in the air. So iron, the atomic mass, the mass number of iron is actually 50 something, I think 56 or so. Then when it adds on to oxygen, so automatically when iron rusts, the answer is that it becomes what? Heavier. When iron rusts, it becomes automatically heavier. So the correct answer is option B. This is according to Lavoisier, who actually introduced the idea of conservation of matter, that matter is neither created nor destroyed, but can be converted from one form to another. So if iron rust, please don't be deceived, it gets heavier and not lighter. And not only that, when iron rust, it gets oxidized and becomes heavier. Now the next question number 3 says, forcing a neutron into the nucleus of uranium-235 will A, increase the mass number of uranium atom, B, have no effect on the size of the uranium atom, C, split the uranium atom. Then we have D, cause nuclear fission between uranium atoms. Listen, this question is actually tempting you. Do you know how nuclear fission was discovered? Actually, it was discovered by Lisa Meitner and the other colleague like Otto Hahn. They were trying to force neutrons into uranium-235, which is one of the largest atoms as of then. They wanted to create more radioactive substance, because the more neutrons are bigger than protons in an atom, the more radioactive. So they wanted to create more. Do you know what happens? They ended up splitting atoms. So, and that is what the question is asking you here. Forcing a neutron into the nucleus of uranium-235 will increase the mass number. No. We have no effect on the size of the uranium atom. No. The correct answer is C. It will split the uranium atom, and that is what we call nuclear fission. Nuclear fission. And in the uranium-235 nuclear fission, as you can see there on the screen, uranium-235, that's we have (235). Okay, let me use normal letter. Uranium-235. Here is 92. Bombarding it with neutron. Neutron have the mass unit of 1 and 0 charge. It will give you barium, which will have mass number 141. Then here is 56, plus krypton, which will have 92 here and 36. Then plus 3 extra neutrons. So this is what we call nuclear fission. So forcing a neutron into this is the neutron. So forcing a neutron into the uranium-235 will split it so that you have barium and krypton with the release of energy actually. So in this case, you have that energy is also released, which rhymes to E equals mE squared according to Albert Einstein. E equals mc squared. So we go to the next question. Okay. So we lift the next question, which says, I can't find it. Okay, yeah. So here we have question number 4, says, which of the following oxides will not be affected by this reducing ability of the strongest reducing agent? So this question is trying to let you know about the extraction of metals actually. So the answer should be, you use your activity series for metals, that is potassium, sodium, you move down the activity series of metal. I will just explain that now. When we come here, what we have is, okay, let me use this thread. The activity series should be potassium, sodium, calcium, magnesium, aluminium, zinc, and iron has zinc, tin. That's after iron we have tin. Then we have lead. Okay, after lead we have hydrogen, which is just there as a control. After hydrogen we have copper, silver. Okay, we have mercury before silver. That should be copper, mercury, silver, and gold. So this is the activity series actually of metal. Then what you should know here is this, that this first one, that's starting from potassium, sodium, calcium. Let me highlight them. These ones are only extracted by electrolytic reduction. Then these ones here, from zinc to lead, that is, are extracted by thermal and chemical reduction. Then these ones here, the last but not the least, actually, okay, hydrogen shouldn't be there. Hydrogen is not a metal. So these ones below are the least reactive. So here are very reactive. They are very reactive. And these metals are only extracted by thermal reduction. So there is no reducing agent that will ever reduce the oxide of potassium, sodium, calcium, magnesium, and aluminium to its metal. Therefore, looking at the question, look at it well. Question number 4 here is saying which of them. So looking at them, copper is below, then zinc cannot, then iron. So zinc can be extracted by reduction. That of iron 3 oxide can be reduced using carbon 2 oxide or carbon 4 oxide. Then potassium oxide is the correct answer. The answer is A. So you cannot reduce potassium oxide using any strong reducing agent. Therefore, according to what I just told you here, these very reactive ones are extracted by electrolysis. That these ones I highlighted in purple, then these ones highlighted in yellow are extracted by thermal and chemical reduction. Then these ones below are actually mined as free metals. These ones are mined freely. Then you can purify them with electrolysis. Then we go to the next question. Okay, well, let me clean up this. The next question, number 5, says, what is the shape of ammonia molecule? Please, the answer is actually A, trigonal pyramidal, not trigonal planar. The reason for this is we have 2 trigonal here. No one should ever take B or C. But the question is to tempt you, is it A or D? It is trigonal pyramidal because of what we call repulsion between lone pair and bond pair. So in this aspect, what you have is, look at ammonia. Ammonia by structure, we have this molecule. Ammonia have 5 electrons in the outermost shell. That is for nitrogen because it's the reaction of actually 3 atoms of hydrogen with 1 atom of nitrogen. This is actually planar, but that's not the shape. In real sense, nitrogen is number 7, which has KLM. That's for nitrogen, which is 2 and 5. Then we have that for, in that case, the main shell we are looking at are those ones that are 5. So you have 2, 4, and 5 of them. So coming here, it shows that we will equally distribute these electrons for better understanding. So let us distribute them separately. So we have 2 here. Then here we have 1, 2, and 3. That makes it 5. Then remember that hydrogen is only 1 this way. So when one hydrogen comes in, it brings 1 electron and they pair together. This is hydrogen. Then another hydrogen coming in, they pair together. This is hydrogen. So this is the bond holding them. Then another hydrogen comes. You see that the nitrogen has attained octet stability, while the 3 atoms of hydrogen has also attained duplet stability. So in this case, look at, there are things you should know here. We should call here. Now, let's call the distance between these. Remember that this is what we call lone pair, while this is bond pair. So in ammonia molecule, there are 4 bond pairs and 1 lone pair. So this is 1 lone pair. So here is a lone pair, while these ones here, the highlighted there in yellow are bond pairs. Then the one in, okay, let me take it there, purple. Okay, sorry. So the one here, the one in purple is actually a lone pair. Now we have attraction and repulsion. Let's call this place A, B, C, and D. What I mean, the distance between this pair and this pair, let's call it A. This is what we call, the repulsion is called lone pair, bond pair. And here is called bond pair. C is also bond pair. Then D is lone pair, bond pair. So A and D are actually lone pair, bond pair repulsion. Now, there is higher repulsion between this lone pair and bond pair. And that pushes, eventually pushing the hydrogen atoms. Instead of being planar like you see here, it will now be in this form, such that the hydrogen will tend to come together to form a pyramidal shape in this case. So the answer is trigonal pyramidal. This is the correct shape of ammonia molecule. We now go to the other questions. Let's clean the board. Please remember that I'll be a bit fast, and I hope you are there with your questions also, because we are here to do revision. Okay. The next set of questions are, we will go to number 6 and 7. So we have here 6 and 7. So let's remove. So we bring this up. So over here we have 2 cylinders. You have to be careful with question 6. 2 cylinders X and Y each contains 120 cm³ of fluorine and neon respectively at the same temperature and pressure. If 2.5 moles of neon is present in Y, then the mass of fluorine in X is, remember the molar mass of fluorine or the mass number of fluorine is 19, that of neon is 20. Here, the major aim is just to understand something. Try your ability. Let's see if you can solve this. First, because of time, because I would like to welcome your questions also. one thing you should know is this. According to Avogadro's hypothesis, that equal volumes of gas at the same temperature and pressure have the same number of moles. So it shows that if 2.5 moles of neon is present in Y, there is also 2.5 moles of, it shows that there will also be 2.5 moles of fluorine in 120 cm cube. So according to Avogadro's hypothesis, equal volume of gases at the same temperature and pressure will have the same number of moles of gases. So considering this, your job is now to, let's go back to our solving board. Okay. Let's clean up this. The volume given was so we have that volume of fluorine, don't mind this is not thorium, we are talking about fluorine, please. The volume of fluorine as we see there is 120 cm cube. So then the number of moles is where our interest is, the number of moles. Moles is 2.5. Then remember, (2.5), please. Okay. So the number of moles actually is 2.5. Then, which means that, remember the molar mass of fluorine is 19. I think as we see there, yes, of course, it was given. The molar mass is 19. And remember, the only secret is that you should know that fluorine is diatomic. Fluorine do not occur as just F. Rather, it's going to be F2. That's how to write it. So what does it mean? It automatically means that so F2 is fluorine. 1 mole of fluorine weighs 19.0, of course. Then your job is just to know that 2.5 moles should now be what? Remember, it's diatomic, which means your job is just to say 19 times 2, which will give you automatically, we have 38 there also. Let me use my calculator here. 19 times 2 is 38, of course. So this automatically shows that 38 is for 1 mole of fluorine gas. So if 1 mole equal to, or rather will give you, that's if 1 mole of fluorine equal to, don't mind this. Okay, let me go back to original pen. 1 mole of fluorine equal to 38 grams. So 1 will give you 38. 2.5 will give you X. Simple. So that 2.5 will give you automatically 38 over 1 times 2.5. So 38 times 2.5 is 95. So the answer is 95 grams. That's the mass. So bringing the question back, our correct answer is C. The correct answer is C. Then, coming to question 7, a gas with rotten fish smell was released on heating an unknown sample with concentrated dioxide in an inert atmosphere. The unknown sample is likely A, sulfur, B, phosphorus, C, nitrogen, D, ammonium compound. I know you'll be tempted answering ammonium compound, but unfortunately that's not what it is. It's not actually ammonium compound.
Hi guys. My name is Shamika Arizi. I am a second year master.
My name is Sushma Tripathi and I'm a first year medical student.
We're here today to ask you to please subscribe to Sir Majesty Easy World.
It has cool experiments and it makes science fun. So subscribe.
Please.
Okay. Still live with Sir Majesty Easy World. I am here to teach you likely questions that will come out in this forthcoming JAMB examination, and also handle your own questions for revisions. Wherever you are finding it difficult, try to ask questions. We are now in question number 7. I only have 10 questions to teach you. Then other questions should come from you. Remember to share this live stream with your friends. I don't want you to fail. I'm looking at you enter the 4 walls of the university. So it's a nice thing knowing that you're there. Remember that Sir Majesty Easy World Science channel is there for you. And it is here that you get acquainted again the main knowledge. Okay, we come back to question number 7. You say this. Listen up, this is all about a gas with a rotten fish smell. Remember, don't answer. Some of you will be tempted thinking about hydrogen sulfide. No, hydrogen sulfide have the smell of a rotten egg, not rotten fish. So the answer here is the gas that have this smell is nothing but the phosphine. Phosphine, that is pH3, which is an analog of ammonia. Remember, phosphorus and nitrogen are in the same group. So NH3 and pH3 are analogous. But you should know that it's a phosphorus compound. That should be the correct word answer. So, and the gas that have this rotten fish smell is phosphine, pH3, called phosphine. So, and how do you produce it in lab? By heating white phosphorus with concentrated sodium hydroxide in an inert atmosphere. That is the way on how to make that. Then we move to question number 8. Question number 8. Okay, 8 and 9, they are all here. But before then, let's remove these ones here. Question 8 and 9. Okay, zooming it in to see clearly. Number 8 says, which of the following is not a sugar alcohol? Option A says isopropyl alcohol, glycerol. Option B. Then option C says ethylene glycol. Then D says inositol. Please, I know you might be so scary about the word sugar alcohol. Now, when you come to alcohols, I'm treating alcohols now for you. You can divide alcohols into monohydric, dihydric, and hydric alcohols. Then just know that polyhydric alcohols are commonly called sugar alcohols. When we say that an alcohol is polyhydric, we are discussing polyhydric alcohols. They are alcohols that have OH in all the. For example, this compound you are seeing there, this is, if you see such compound, this is actually a polyhydric alcohol. Then a monohydric alcohol is actually the one that have one OH in one molecule of it. Dihydric is the one that have two OH, while trihydric is the one that have 3 hydroxy group attached to one molecule of it. But actually, by understanding that when you have more than one OH, you should be regarded as polyhydric, but it is not. You should know that polyhydric alcohols just means sugar alcohols, and it means all the alcohols in which each of the carbon atoms there have OH attached to it. So a polyhydric alkanol is not just an alkanol that have more than one OH. No, it is an alcohol that have OH attached to all the carbon atoms. As you can see there on the screen, you can see that this carbon has OH, this have OH, this have OH. Then, using the common one we know, I'll clean off one group here. If this compound is in existence, as we all know, this is actually in existence. This is called propan 1,2,3-triol, otherwise known as glycerol. So glycerol is a polyhydric alcohol. Why? Because it has OH attached to all the carbons present. So this one is among it. Then if you have ethane 1,2-diol, that is it here. It is also polyhydric. Ethane 1,2-diol, otherwise known as ethylene glycol. Ethylene glycol is polyhydric also. Why? The whole carbon atoms have OH attached to it. So this is polyhydric, is a sugar alcohol. But remember, we have ethylene glycol. Ethylene glycol, meaning if you have a compound like this, not ethylene glycol, so we have propylene glycol. This one is called, here is ethylene glycol. Ethylene glycol. But let me illustrate another compound like this. If you have OH here and OH here, this is actually dihydric alkanol or dihydric alcohol, but it's not polyhydric. It is not polyhydric. Reason, look at this carbon here. This carbon have no OH attached to it. This carbon has no OH attached to it. Let me highlight it. This particular carbon, but it is only this one. So this is not a polyhydric alkanol. Not polyhydric, but dihydric. Just like these two are all dihydric, but this is polyhydric and this is not polyhydric. This is also polyhydric. So this is not polyhydric. Now, checking the options, watch well. Option A says isopropyl alcohol. Do you know what isopropyl alcohol means? IPA, known as, just the IUPAC name is 2-methylpropanol. 2-methylpropanol is not, it is monohydric. So no monohydric alcohol is a sugar alcohol. So the answer actually should be A. Glycerol, as you have seen there, is propan 1,2,3-triol, which is a moisturizer. Ethylene glycol is ethane 1,2-diol. Then inositol is cyclic sugar alcohol. It's cyclic in form and usually occur in biological system, inositol. So the correct answer is isopropyl alcohol. We now go to question number 9. As you can see there, question number 9. Okay, so let me clean off these ones. Gonna cut off all these. Okay, question number 9. So over here, which of the following is not polymeric? Polymeric is just asking you which of them is not actually a polymer. It's not actually a polymer. The options there have natural polymers, of course. Protein, all proteins are natural polymers. Cellulose is a carbohydrate that is a polymer. Cellulose and starch are all polymers. Remember, polymers are giant molecules built by many monomers. So the answer should be C. Lipids are not actually polymers. Lipids are not polymers. They are giant molecule, of course, but not giant enough to be called polymers. Please note it. All proteins, no exception, are polymers. Cellulose are polymers. Then lipids are not, starch are not. Now, at this particular point, you should know the difference between macromolecules and polymers. Actually, all polymers are macromolecules, but not all macromolecular substances or compounds are polymers. For example, you can see lipids are giant molecule found in our body in biological system, but it's not polymeric. Another one is diamond. Diamond is a macromolecular, is a giant molecule, but it is not what? A polymer. So they are just trying to know if you know the differences between polymers and ordinary macromolecules. All polymers are macromolecules, but not all macromolecules are polymers. Fats and oil is not polymeric. Protein is polymeric. Starch is polymeric. Cellulose is polymeric. Remember, not all carbohydrates are actually polymeric. We now go to the last question for the day. The last question today should be, we will lift it here. It's actually the last but not the least question. Okay. So the substituent group that is one hydrogen less than that of benzene is, you know what we call substituent group? If you are not careful here, you might get it confusing. Actually, a substituent group is a group that takes the position of hydrogen in an organic compound. Then here I will why bringing in all this? Let me create a new note. It's giving me tough time. Let me just create a fresh page. Okay. Now the question, I'll bring it out again. Question number 10. Yeah. Here we go. So in the explanation, you will see something. You are talking about substituent groups. So the group that takes the position of hydrogen in an organic compound is called a substituent group. Then, as we all know, benzene is actually written C6H6. Then they are asking us the one that is one hydrogen less, and that should be C6H5. And this is what we call phenyl or allyl group. So the correct answer is phenyl. Then alkyl, as you know, is just methane minus one hydrogen, which have CnH2n plus one hydrogen. That is for methane. That's alkyl. Then benzyl, look at the option C. Benzyl. Don't confuse benzyl with phenyl. Then benzyl is just actually extra. Let's have a structure here so that you see a benzyl. So I think we have benzyl here. Yeah, this structure here is benzyl, having a benzene ring with CH2 attached before it attaches to the main thing. See what I mean here? If you have benzene, let's assume this is a straight chain. Okay, let me use a reduced form. Let's assume we have a compound like this, and you have benzene. This is just called phenyl because the hydrogen that's supposed to be here has been displaced out, so that what we have is ordinary. Instead of having something like this, you have only one. There should be circle here, H. 5H will be there. Then the H that's supposed to be here will be used to attach to the main chain. So we have nothing but 1, 2, 3, 4, 5, 6 carbons and actually 5 hydrogen. That's phenyl. So if you want to name this is carbon 1, 2, 3, 4, 5. So this should be actually 2-phenyl. So this is a substituent group. But when it attaches to the main chain, just compare these two things. Before the benzene, before it attaches to the main chain, let's assume we still have something like this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah. And it will come out in this form. you see something bending to give you watch what I mean. Then the benzene attaches. So there is remember why drawing this structure, every sharp bend means carbon. Like here, carbon, 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 carbon. So we have how many carbons here? We have 1, 2, 3, 4, 5, 6. So but the nearest one should be 1. Then here is also a carbon because of the sharp bend. We don't have anything like that. We don't have anything like, you say what? Why did I, in number 4, why did I exclude? Okay, I'll still come back to your question, please. But let's focus here. In correct numbering, I think this should be cover number 1. Here it should be 2, 3, 4, 5. But what I want to let you know is that there is another carbon here, which is this, before being attached. So this group here is actually called benzyl. Benzyl group. Benzyl, that is another carbon attached to it. But this group here is called phenyl. So a benzyl group is actually summarized by why is this thing blocking? So please, this is actually a benzyl group. So looking at the back to what they gave us is this. So what is the answer to number 9? I've answered number 9. I told you that number 9. Okay, let me recall the question, please. What did number 9 say? Question number 9 says C is the answer, please. Lipids are not polymeric. Stop taking us back. Lipids are not polymeric. Proteins are polymers. I say polymeric means those that are polymers. Then cellulose is polymeric. Then starch is polymeric. But lipids are not. So coming to question number 10, actually, what we have is that the answer is nothing but the answer is phenyl. So that's it. Now, if you have your questions, please, I'll be here to welcome them all. Remember that phenylene is, I'll still give you more time to explain this. By molecular formula, phenyl is, or what we call phenyl, is actually C6H5. Then the other option says alkyl is actually CnH2n plus 1. Then benzyl is actually C6H5CH2. So which means in total you have C7H7. That's what we call benzyl. Then the other one, phenylene. Phenylene is just removing two hydrogens. So we have C6H4. So these are actually substituent groups. So that's it. Now, thanks for being there. As I wait for your questions, remember you are still live with Sa Majesty, and your questions is what I'm waiting for. Questions, please. For those of you that are still online, bring your questions or I'm ending the live stream. Time to ask your questions. Time to ask your questions. I'm looking at the screen. No question is coming. At least I know about 5 or 10 of you are still online. Okay. In number 4, why did you exclude hydrogen? What is the answer to the number 9? I've attended to that. Number 4, let me see that question. Number 4, actually, what did number 4 say? Okay, in activity series, okay, I now understand what you mean. Hydrogen is not actually a metal. We are talking about activity series of metal. Hydrogen is there as a determinant, just to tell you those of them that can displace hydrogen and those of them that cannot displace hydrogen. That is why I excluded hydrogen when I was explaining the activity series of metal. Hydrogen is there as just a control, not that hydrogen is a metal. Your questions, please. I've exceeded my time actually by a minute, but I'll still give about 10 minutes grace. Bring your questions. Bring your questions. Your questions, please. Your revision questions.
Hi guys.
My name is Shemika Arizi. I am a second year medical science.
My name is Supra Tipati and I'm a first year medical student.
We're here today to ask you to please subscribe to Sir Majesty Eating World.
Bring your questions, please, in the live chat.
And it makes science fun. So, subscribe.
We are doing our first stream. Next stream, please, will be on Friday. That should be next tomorrow, the same time. That's 2:30 p.m. GMT +1. That should be the time zone. Okay, what do you say here? What is the shape of water molecule? Water molecule is actually angular or bent. That is the shape of water molecule. Let me draw it for you to understand. Shape of water molecule. Water is angular. Yeah, more questions, please. Water molecule is bent or angular, and that's what I'm illustrating here. Remember, water, the formula is actually H2O, meaning we have 2 hydrogens and 1 oxygen. So you say, what is the shape of water molecule there? I'm on it, please. Answer to number 10 is lipids. Lipids. Okay, sorry, number 10. The answer to number 10 that is there, it should be phenol. That phenol is just a substituent group formed when there are 1 hydrogen less in a benzene ring. Remember that benzene is C6H6. So when you remove 1 hydrogen from it, it becomes C6H5. That is what we call phenol. Then for water, in the covalent combination of water, oxygen has 6 electrons in the outermost shell, of course. Then this makes it 6. Then 1 hydrogen will come in and now bring the only electron it has. Another one will come in, and this is what we call hydrogen. This bond pair, like I told you in ammonia. So in water, there are 2 lone pairs, unlike in ammonia, where we have only but 1 bond pair. So you have here, these are lone pairs, then these are bond pairs. So we have, in water, there are 2 bond pairs, and there are 2 lone pairs. You said I haven't answered your question. What was your question, please? Ibokwe? What's your question, please? So the person that asked about water molecule, I think it is clearer now. So water, by drawing the shape, again, you have that this should be oxygen, and this should be H, and H. This is angular or bent. Why does the uranium atom split when a neutron is added into it. Yes, because it is unstable. It's not every uranium actually that splits when a neutron is added to it. Like uranium-238 is not all that fusile, meaning if you bombard it with neutron, it will absorb it. So, but uranium-235 is actually fissile, so it will split because of the instability. It's just showing that the larger an atom becomes, the more unstable it is, especially in nucleus aspect. So when you now bombard it with a fast-moving stream of neutrons, it will split it into two, giving you a lesser atomic one with the release of energy, which is equivalent to E equals mc squared, according to Albert Einstein. So small revision on organic chemistry, that should come Friday. Please try to be here on time, as it is here on time. Immediately it is 2:30. I will take you on JAMB. Bring your JAMB questions, please. Thank you so much for watching. That brings our live stream to end today. I really value you, and it is nice to see you.
Thank you for watching. I love you. Thank you for watching.